This is the second video on homework review for test number 3 in Math 110 for the fall of 15. So the first problem I want to go over in this video is problem number 1 from homework number 8. So in this one we have the equation 2x minus y is equal to 2, and we're asked 3 different problems that relate to this equation. So the first thing that I want to do in this problem is, because I'm being asked to see which graph it is to identify that on a graph, is easiest if I go ahead and solve this equation for y. So I'm going to go ahead and I'm going to add y to both sides to make the y positive. Now you might think that's kind of an odd thing to do, but it's not going to be any more or less work than if I had left the y alone and brought the 2x over to the other side. So now I'm going to have 2x is equal to 2 plus y. And then I'll need to bring the 2 over to the other side. And so I will now see that I have 2x minus 2 is equal to y. So what's great about this is now I have slope-intercept form. So this is, oops, that was an eraser. That is my slope. And so I can tell the slope is positive. So I can look at these 3 lines and go, oh, that one slides down. That's a negative slope. That first one is not my possibility. These two are both positively sloped lines, so those are a possibility. So now I'll go ahead and I'll take a look at the next important feature, which is this y-intercept. So now I can go and I can look, okay, my y-intercepts. Oh, well, this line can't be it because it crosses at -1, where this crosses at -2. So this middle line right here should be my my y-intercept. Which should be my correct graph. So I'm just going to call it B. Now I need to label a point. So I can label any point on this. So I could obviously label the y-intercept, but I'm going to go ahead and go out on a limb and I'm going to label the x-intercept here. So I'm going to label this point right here, and I obviously can't do it on this graph, but I would label that point right there. And that would be the point +1, 0, and I'd label it on my paper right there. I'd put a dot and I'd label that point. Now I'm going to check to see if that's a solution. So what I need to do is I need to put this x coordinate and this y coordinate into this original equation, not the one I've changed, the original one, just in case I made any mistakes. So 2 times x, which is 1, minus 0, which is y, is that really equal to 2? That's what I'm finding out. I'm not resolving this. I'm not doing anything but putting that in there just to make sure it's a true statement. 1 times 2 is 2 minus 0, which is still 2, and that's equal to 2. That's a check. So that is indeed my solution. So that's problem number 1. Now the next problem I want to go over is problem number 2. So I'm going to scroll down and catch up number 2. So again, this is the equation that I have for problem number 2. And I want the x and the y-intercept. Well, to get the x and the y-intercept, I really don't need to have it in slope-intercept form. I could, but I don't need to. So finding the x-intercept, that's where it crosses the x-axis. So on the x-axis, I would have an x value, but my y would be a 0 coordinate. So that's how I find my x-intercept. I let y equal to 0. So this says 2x plus 5 times 0, that must be equal to 10. So that's really gone, and this is just dividing both sides by 2. So now I know that my x must be equal to 5. Now it says as an ordered pair, so I'm going to say x is equal to 5 and y is equal to 0. Now the next problem, I'm going to be finding my y-intercept. Now my y-intercept could be found by putting this in slope-intercept form, or I again realized that the y-axis is where that y-intercept would be, and so I would have some y value along here, but the x it would line up with would be 0. So I can let x equal 0 in order to find the y-intercept. So 2 times 0 plus 5y, that's equal to 10. So this is obviously 0, so I can just divide both sides by 5, and I see that y is equal to 2. So my y-intercept, x is equal to 0, y is equal to 2 as an ordered pair. Now I have an x and a y-intercept. Now I need to find a third solution. Now when it says a third solution would not be one of these two. That would just be the same one over again, so I have to do something different. So I'm going to go ahead, and I'm not solving this thing for the slope-intercept. I'm just going to put in a value of y here, because if I put in y, I have to divide by 2, and that's easier to do than dividing by 5, by finding an x, because I want an integer ordered pair. Non-integer ordered pairs are very difficult to graph, and therefore they don't make very good graphs. The solution then may be a little off, and I don't want that. I want it to be very exact. So positive 2 worked for a y, so let's try negative 2 and see how that works. So 2x, and I'm going to say let y equal negative 2. So I'm going to put in a negative 2 for y. And remember, that's perfectly acceptable. I can put in any y that I want to and solve for x, and I can put in any x I want to and solve for y, because we know that in a linear equation, all x's and all y's will eventually be part of the solution. So right now, what I'm doing here is I'm going ahead and I'm adding in 10 to both sides. So I have 2x, which is equal to 20, and now I'm going to divide both sides by 2, and that is going to give me my x is equal to 10. So now I have my ordered pair solution as x is equal to 10 and y is equal to negative 2. So now I have 1, 2, 3 points to graph, and remember, I always tell you that I would like you to graph 3 points for me. So we're going to go ahead and plot these 3 points. So they're my x-intercept, x is equal to 5, and I'm going to put that point right there. And I'm going to label it with my ordered pair, because remember, that's one thing that I also ask always that you do is label your points. Then I'm going to plot my y-intercept, my 0, 2, oops, that's 0, 3. There's 0, 2 right there, and I'm going to label it with its point, its ordered pair. And then I'm going to plot the 10, negative 2. So there's 6, 7, 8, 9, 10, 1, 2, down. So there's my point right there. And again, as I mentioned before, it's really hard for me to draw perfectly straight lines. I can't get a straight edge out on the bamboo tablet, but I would expect that you would get a straight edge out and you would draw a perfectly straight line all the way through the points and across the coordinate system, put arrows on the end of it, and wrap it up by labeling it with its name. 2x plus 5y is equal to 10. And that will conclude that problem. So our next problem that we're going to move on to is problem number 4. So in problem number 4, we're looking at whether these relations are functions or not. So I have a visual of this one, and so I'm going to look at it and go, oh, wait a minute, it does not pass the vertical line test. That means that this isn't a function. Every x value doesn't have one and only one y value. So this is not a function. And I'm going to use function notation there to denote that it's function, right? So that's shorthand for function. It's not a function, and that's because it fails the vertical line test. Now, if you're going to call the vertical line test, if you're going to use the vertical line test, then you have to have a visual. So we do, so there it goes, because it fails the vertical line test. All right, next we're going to go on to this equation. Now this equation, I recognize, and I've talked to you guys about that, this is an absolute value equation. So I know that this thing is going to be a v like that, because that's what all absolute value equations look like. And furthermore, I could tell you that this one is going to have this thing called a vertex, at x is equal to 3 and y is equal to 1. So I could give you a little bit of context about that, and once I have a graph drawn on this thing, I could say, oh, look, this thing is going to pass the vertical line test, right? Doesn't matter where I draw lines through this, there's not going to be any of them that are going to hit the graph more than one time. So this one is a function, and the reason is because it passes a vertical line test. And I can do that because obviously I've drawn a picture of it. And so if I have a little context about the different types of functions, I can certainly do this. So because it passes the vertical line test. So I'd like to kind of show you something here. So let me finish writing this and then let me pull something up on my screen to show you some of the functions. And this is a cute little diagram. And I think I talked about this in class, but I don't think I showed it to you. So this is the cute little diagram that I wanted to show you. I call this the function dance. And these are all the different types of functions that you'll eventually encounter in pretty much all of your algebra and pre-calculus and trig classes. And these little people are showing you what they look like. So if you have a little bit of an idea of what these functions look like, so here's our absolute value one, and you see the general idea here is that shape. And there's the positive absolute value that we see, and that one has a positive shape like the V. So anyway, that's just a cute little thing. I call it the function dance. So I just thought I would show you that. All right, now moving on to our next one here. And on this one, what I'm going to notice is I'm going to notice that value there and that value there and that value there and that value there, and the x's, they're all unique. So since I have all unique values of my function, or in my function, I know that this one is definitely a function because there are no repeated x's. That means there's no possibility for an x having more than one y. So this one's a function because there are no repeated x's. And I'll allow you to just say that there's no repeated x's. And that's because you can't have two x's that give you, or the same x that gives you two different y's. So if there's no repeat, there's no possibility of that happening. Now looking at part D, we have a 0 for x, a 5 for x, and a 3 for x. So again, on this one, I'm looking at the x's again, and again I have no repeats, so I'm going to say the exact same thing, is that yes, it is a function because there's no repeated x's. Oops. All right, now moving down to this next one. This one always kind of confuses students because this one, the one that hangs people up is the fact that 3 goes to 7, 2 goes to 7, and 4 goes to 7. That right there, that the fact that all these go to 7, that's okay. What is really the killer here is this one right here, that 2 goes to both 6 and 7. That's what makes this one not a function. So the fact that 2 goes to both 6 and 2 also goes to 7, these two are what make this not a function because there's the repeated, the x's that go to two different y's. So that one is not a function. And I would just say x to 2 y's on that one. All right, so that was number 8. Now let me go back here and see where we are. Okay, so that was number 4, sorry. So we've now taken care of these, and I think that that's probably a good place to stop this video, and then when I come back I can do 6, 7, and 8 on the next video. All right, see you in the next one.